All right, notice that the clouds in this picture show a little bit of motion this way. If you see pictures of the Earth where they show the cloud patterns and we have hurricanes and we have highs and lows and we have very complicated weather, Venus doesn't. It's actually very simple. Why? Because it's rotating so slow that it hardly changes. Also, the clouds act like a blanket, so from daytime to nighttime temperature isn't as extreme. It's the extreme differences in temperature on the Earth that cause air to get higher density, lower density, and air to move from one place to another, which is what's caused all our weather. When everything is about the uniform temperature, it doesn't change that much. And when it rotates slow, you don't get the spinning and things. So all that changes the weather completely on Venus as compared to the Earth. Now this is a map of Venus. In fact, I have a Venus globe right here. This is a globe of Venus. Now if you look at that, and the colors, remember, do not represent, colors represent elevation. They have nothing to do with the color of the land. It's kind of interesting. They make the blue like this, and you think, oh, those are oceans. Well, no, there's no water on the surface of Venus. Why? Because it's so hot, the water would immediately become a vapor, and then that hot water can actually move through the atmosphere, the vapor, and get dissociated by the ultraviolet molecules. And then it recombines. The hydrogen combines with the sulfur. The sulfur comes from the volcanic activity. It has active, well, we think they're active. Nobody's quite sure. It had active volcanoes for sure. We're not sure if they're still active. There's some sign that they might be. But that's what recombined. That's how we get sulfuric acid, H2SO4. So the water is gone. We think that Venus originally had as much water as the Earth did. It's the same size, formed in the same way. So it probably had thick oceans, but they're long gone. Now we see it has two kind of major continents here. A major one up here and right here, and a bunch of little islands if we look at it and we try to compare it to the Earth. And these are volcanoes. This is the highest mountain on Venus. It's called Maxwell Mons, named after the physicist James Clerk Maxwell. And here it is. Now this is not a real picture. This is a picture. They took a satellite and they orbited the planet and they used radar bouncing those radio signals off of it to see through the clouds. And then they mapped it so they could map all the continents and the mountains. And this is a computer generated model from that. It's the same way they've mapped all the ocean floors, except they use sonar in the ocean. Here we did radar out in space. So, and this is not true color, so that's not what it would look like. Now, we do have pictures from the surface, which is really cool. Back in 1975, so this is October 22nd, 1975, and I don't know what that says, but if you could read Russian, actually this is the Soviet Union, back when it was CCCP. The Soviet Union landed the spacecraft on Venus. So what happened, you got to think about the race to the moon. Well, the race to the moon, the U.S. beat the Russians there in 1969. And then we went to the moon from 69 to 72. And then by that point in the mid-70s, they said, oh, well, let's go beyond the moon. Let's try to explore other places. And we decided to go to Mars. And so we sent our probes to Mars at that time, our Pioneer. And we sent probes in 77 further out to Jupiter and Saturn. That. But Russia said, oh, well, if they're going to do that, let's send it to Venus. So they decided to send it to Venus. All right? This is Venera 9 and Venera 10. This is what the surface looks like. Now, the atmosphere on Venus is super thick. I mean, really thick, like 1,000 times thicker than our atmosphere. If there was just a few mile per hour wind, it would knock you over. It would be hard to move. It's kind of like the pressures you would feel at the bottom of the ocean. So, very different than our atmosphere. Very, very thick atmosphere. And so there was lots of challenges, and all their spacecraft, they landed several of them there. None of them lasted more than about 20 minutes. Because the high pressure, the high temperature, nasty conditions of the sulfuric acid that you had to descend through to get to the surface. So they didn't last very long. But what's amazing is that they got pictures back at all. So here are pictures of the surface. It looks kind of like the rocks and stuff you would see in the interior of a volcano on Earth. Here there's more pictures. This is the edge of the spacecraft here. Right here. Yeah. And this was an experiment they had where they had an arm they would release when they got there, and the arm would fall down and it would bounce. And how high it bounced would tell you something about how hard the surface is, right? If it was like concrete, it would bounce really high. If it was like sand, it wouldn't bounce at all. So it was a way to measure how hard the surface was. And this was covers on this that came out. In fact, one of their experiments didn't work well. The cover, when they get there, the cover is supposed to pop off. Well, the cover popped off, but it popped off exactly where the arm fell. And so what you really did was measure how hard the cover was instead of the actual ground. But when you're millions of miles away, there's nothing you can do about it. In fact, this is the one right here. You can see the cover right there. They fell right on the cover. This was Venera 14. So there were several different ones that they sent there. And this is the surface. You look like it's a rock. This is all igneous rock, which comes from volcanoes. These are color bands over here. So they said, okay, we can only send black and white cameras, especially back then. But we can colorize them if we know what colors they're supposed to be. So these are specific design colors so they can colorize it. And so they actually colorize some of the pictures. And this is what we think the color of it would be. So this is what it would look like in the color. Now that orangish reddish glow I told you is because most of the blue and all that has been scattered out in the atmosphere. It doesn't make it to the surface. The only light that actually makes it all the way down to the surface is this reddish glowing light. So that's the way it would look if you can make it to the surface of Venus. But those are pretty cool pictures. Those are pretty much all we have from the surface of Venus. There have been no other missions launched to go to the surface of Venus, mostly because it's such an inhospitable place. It's too hot. It's too nasty. There's no way humans would ever survive there. There's nothing we can do with this planet. So other than scientific curiosity, there's no reason to go back to Venus at this point.